Welcome viewers. In this video I am going to solve question number 1 from exercise 7.3. Triangle ABC and triangle DBC are two isosceles triangles on the same base BC, and vertices A and D are on the same side BC. If AD is extended to intersect BC at P, show that number 1, triangle ABD congruent to triangle ACD. Number 2, triangle ABP congruent to triangle ACP. Number 3, AP bisects angle A as well as angle D. And number 4, AP is perpendicular bisector of BC. Let's go through the question once again slowly and start solving the questions one by one. What is given here? Triangle ABC and triangle DBC are two isosceles triangles on the same base BC. That is, for the triangle ABC, we have BC is the base, and therefore we can say this side equals to this side. And according to the question, triangle DBC means DBC, this triangle is also an isosceles triangle with base BC. So we can say in the triangle DBC, DB equal to DC. That means this side equals to this side. And the vertices A and D are on the same side of BC. We observe that both the vertices A and D are on the same side of BC. If AC is extended to intersect BC at P, look, this line, that is AD. So extended AD intersect BC at P. We have to prove these 4 things. Let's start proving the first question. We have to prove here triangle ABD congruent to triangle ACD. That means this triangle congruent to this triangle. In triangles ABD and triangle ACD, we have AB equals to AC given. Number 2, DB equals to DC given, and AD is the common line. AD equals to AD common. Therefore, triangle ABD congruent to triangle ACD. Look once again, we are going to prove triangle ABD congruent to triangle ACD. What I have written here, in this triangle ABD and ACD, AB equals to AC. Why AB equals to AC? Because ABC is an isosceles triangle in which this side equals to this side. It was given. Next criteria, I have written DB equals to DC. Also, it is given that DBC is an isosceles triangle. Therefore, we can say DB equals to DC. This is also given. And for both the triangles ABD and ACD, we have AD as a common line. Therefore, we can say AD equals to AD common. So, triangle ABD congruent to triangle ACD by SSS criteria. Next, we have to prove triangle ABP congruent to triangle ACP. For proving this, we need three criteria. We already have two criteria, that is, in triangle ABP and ACP, AB equals to AC and AP equals to AP, that is common side of both the triangle. Another criteria is required. Let's find it. We have already proved triangle ABD and triangle ACD are congruent, since triangle ABD congruent to triangle ACD, therefore this angle equals to this angle, that is angle BAD equals to angle CAD by CPCT. These angles are the corresponding parts of congruent triangle. Now BAD means BAP and CAD means CAP. So CAP. Now in triangles ABP and ACP, we have AB equal to AC given. This side equals to this side given. Angle BAP equal to angle CAP. I have written this as we have already proved this here. So proved earlier. And we also have AP equals to AP. AP equals to AP common. this side is common to both the triangles. Therefore, triangle ABP congruent to triangle ACP. This is side, angle and side by SAS congruent rule. So that's all about the question number 2. Now, third part of this question, we have to prove AP bisect angle A, that is AP bisect BAC, and AP also bisect angle D. That is, we are going to prove angle BAD equals to angle CAD and angle BDP equals to angle CDP. We have already proved that triangle ABD congruent to triangle ACD. Since triangle ABD congruent to triangle ACD, therefore angle BAD equals to angle CAD by CPCT. These two angles are the corresponding parts of congruent triangle. Since these two angles are equal, therefore we can say AD bisects angle A, that is AP bisects angle A. Now we are going to prove this angle equal to this angle, that is DP bisect angle D, that is AP bisect angle D. Since triangle ABD congruent to triangle ACD, that is this triangle equals to this triangle, we already proved these two triangles are congruent. Therefore we also can say this angle equals to this angle, that is angle ADB equals to angle ADC by CPCT. Now angle ADB plus angle BDP equals to 180 degree. Linear pair. This is a straight line, so therefore this angle plus this angle equals to 180 degree because they are linear pair, and angle ADC plus angle CDP equals to 180 degree. They are also linear pair. This is a straight line, so therefore this angle plus this angle make a linear pair. From these two relation we can say angle ADB plus angle BDP equals to angle ACD DC plus angle CDP. Sum of these two angles equal to 180 degree and sum of these two angles equal to 180 degree. Therefore, sum of these two angles must be equal to sum of these two angles. Now we can cancel these two angles because these two angles are equal. We already proved. BDP equal to CDP, since angle ADB equals to angle ADC. Therefore, we can say DP bisects angle D, which implies AP bisects angle D because DP and AP are the same straight line. So we proved third part of question number 1. Next we have to prove AP is perpendicular bisector of BC. That is, AP is the bisector of BC as well as AP is perpendicular on BC. That is, we have to prove BP equals to PC and AP perpendicular on BC. That is, angle APB equals to angle APC equals to 90 degree. I have drawn another diagram for your convenience. Now, in question number 2, we already proved triangle ABP congruent to triangle ACP. Since triangle ABP congruent to triangle ACP, therefore BP equals to PC by CPCT. If triangle ABP congruent to triangle ACP, then BP must be equal to PC because they are the corresponding parts of congruent triangle. And also we can write angle APB equals to angle APC. These are also corresponding parts of congruent triangle. Now, angle APB plus angle APC equals to 180 degree because they are linear pair, and we already have APB equals to APC. So instead of APC I can put APB. Therefore APB plus APB equals to 180 degree. That is, 2 into angle APB equals to 180 degree, which implies angle APB equal to 180 degree by 2, that is 90 degree. Therefore angle APB equals to 90 degree. Since these two angles are equal, therefore angle APB equals to angle APC, both are 90 degree. That is, angle APB, this angle, and angle APC means this angle, both are 90 degree, so AP perpendicular on BC. Since BP equal to PC proved earlier and AP perpendicular on BC, therefore AP is perpendicular bisector of BC proved. So this is the fourth part of question number 1. No more today. I wish you all the best.